So here I have a source of light which will have wavelength lambda and intensity I. So these are photons. Please do have imagination. This is very important. So these photons, they're incident on this one. Oh. This photo cell is a glass tube. It's a glass tube. So first let me draw the emitter. There's a emitter, there's a cathode. There's a bulb having wavelength lambda and intensity is high. What is that intensity? How to vary intensity? By moving the bulb near to the window. This particular thing is called like a window through which the light will enter, and these are the photons. Let's show a few that one. And first I will here I'll be having a key galvanometer which will show the direction of flow of current and one emitter. There's an on off key. There's an emitter. Milliammeter, micrometer, whatever be that. And this is called like a emitter. Let me show red color. This is and this is a collector. Okay, now these are the photons. The energy of photons depends on this one. This particular emitter, this is a metal plate. So this is called like emitter, or it's called like a cathode. This is called like a collector or anode. And this will have a work function of this metal of the emitter or cathode will have work function phi that one. Now a light is incident, the photons are incident. So what will happen here now? What actually happens here? So we'll get three types of photoelectrons will be ejected. No, those electrons which are near to surface will interact with photon. They'll emerge with a maximum kinetic energy. The three electrons I'll show by different color. The maximum kinetic energy electron I'll show it here. No, the maximum kinetic energy electron I'll show by this color. This will be K max, and there'll be another electron which will be ejected with kinetic energy which will be less than K, and there'll be another electron will be there which will be at rest here. So we'll agree this, I think, yesterday. And what is K max? How to write expression for K max? K max should be equal to energy of photon minus work function. Energy of photon SC by lambda, or HF, anything. So this is a maximum kinetic energy photoelectron. Then there are some photoelectrons which will have kinetic energy K. Why this K max? A photon which will come here, it will interact with electron which is present, free electron which is on the surface. After interaction or pen, it will come out with a maximum kinetic energy. And what about this? This much of energy should be utilized to overcome that resistance or the attractive force due to the metal. That's called like a work function. So finally, the difference of energy of photon minus work function is the maximum kinetic energy of photoelectron. And what about K? This will encounter some few collisions. Then will emerge out. When it arrives at surface, it will have energy greater than work function. It will come out with kinetic energy. And what about other electron? It will interact with photoelectron for photons inside the metal, encounter collision. By the time arrives at surface, its energy will be just greater than or equal to work function. So here, it will emerge with a speed almost zero kinetic energy. And what about other set of electrons? They'll encounter, they'll collide with the photon, they'll absorb photon. After absorbing photon, they'll encounter series of collision. By the time they arrive at surface, their energy will be less than work function. They fail to come out. These are the 4 categories of interactions are there, in which 3 categories are able to come out. Now, those electrons which are ejected maximum kinetic energy, they'll start moving towards the anode. Anode means which will collect, or collector, which will collect the electrons here. Getting this? And what about those electrons which are emitted with zero kinetic energy? So this is electrons emitted with zero kinetic energy at emitter form a space charged layer. I'm calling very specifically space charged layer, or finding very difficult to this word, or you can also call it as cloud. Charged cloud. So that charged cloud is what? I'll just show it like this. So what this charged cloud contains, it is made up of and the charge cloud, this should be like this. So what is a charge cloud? Charge cloud, what happen? All those zero kinetic energy electrons happen, they just stay nearby the emitter only, and they'll form a space charged layer. And that is what a charged cloud in the SEOMA is called as a space charged layer. On some books they call it a charged cloud. Those photoelectrons which are ejected with zero kinetic energy, they'll stay at emitter and they'll form some sort of a cloud, and they'll be there only. What will happen to maximum kinetic energy electron? Because of kinetic energy, it start moving. So it will go and collected by the anode, and due to this, anode will collect it, and this particular same electron, now it starts flowing here. Is it justified? I am this electron, it will start moving. Now here it was having maximum kinetic energy. No? What about here? It's a wire, no? Iron or copper wire. With what speed here electron will move? With this speed. Here it was having maximum kinetic energy. What about here? The kinetic energy of electron inside the iron wire should be equal to mass into average speed. What is it? That should be the disk speed. And we know what is the order of this. 10 to the power of minus 4 meter per second. So the kinetic energy electron that moves between emitter and collector, and the kinetic energy of the electron which is moving inside the wire in experiment will be different. Kinetic energy of this electron and the same electron when it starts moving in the wire, no, should have different kinetic energy. Any reason for that? The moment it collides here, the anode will retard its kinetic energy, and because of potential difference, this will start moving. So like this electron will propagate like this here. So this will be the flow of electron. Opposite to flow of electron, a current should be there, and this is called like a photo current or photoelectric current. And if I put emitter will start reading that one. Okay, let's go for the plotting of graph. So let me plot the graph here. Now what about, sir, those electrons only K max will reach? No, those electrons which are having non-zero kinetic energy, they'll come and they'll be collected by the collector, and those electrons inside the wire, all the photoelectrons inside the wire must move with a disk speed.